A rational equation. It is an equation that contains one or more rational expressions. Here are examples of a rational equation. Notice you have an equal sign in it, and equations will always have an equal sign in which you are solving for some variable, whether that's x in this case or p in the other. But yes, you are solving for some variable in rational equations. The objectives of this lesson is to determine the domain of the variables in the rational equation. Without actually solving the equation, let's list all possible numbers that would have to be rejected if they appeared as potential solutions. And then we're going to give the domain using set builder notation form. So recall, to find the domain of a function or an expression, you're basically asking, what are all the numbers that you are allowed to plug in for x? Well, recall, for rational expressions, there's only one restriction, and that is you cannot have a 0 in the denominator. If you have a 0 in the bottom, then the expression is undefined. So in order to find out what numbers are in the domain, just simply find out what values you are not allowed to have that have to be rejected. So looking at the first expression, it's an x. And so if I were to remove the x, what number, if I were to replace it with, would make the first expression undefined? Well, it's certainly not a negative or a positive number, because it doesn't matter whether the number is negative or a positive in an integer. It is not going to make the bottom undefined. The only number that is going to make the first expression undefined is a 0, because if we remove x and replace it with a 0, then the expression would be undefined. Let's take a look at the second expression. It is a rational number, 1/2, and there is no number that would make that undefined because you have 2 in the bottom. There's no variable in the bottom. So at no point are you plugging in anything in the bottom. The 2 will always remain in the bottom. Let's take a look at the last expression. If I remove the x, what number, if I were to replace it with, would make the bottom 0? And again, there is no negative or positive number that would make the bottom 0. The only number that would make the bottom 0 is if you plug a 0 in x's place. So therefore, for this rational equation, we would say that I'm allowed to plug in any real number. The only real number I can't plug in is an x, because that would make it undefined. And the way we would write that in set builder notation form, x is such that x can be any real number, but the one number it can't be is 0, and that is how you would write it in set builder notation form. So again, if I were to plug in a 0 into the original equation, remove the x, replace it with 0, and do the math, we would see that one or more of the expressions here would be undefined, which would make the equation itself undefined. So therefore, we have found the potential number that we would have to be rejected. If I were to go through the motions of solving this equation and x equals 0, I would have to throw out or reject that as a potential solution. Why? Because that number is a number that would make the bottom undefined. And there you have it, determining the domain of rational equations.